Okay, this is your video for 7.4, and we start out with a new theorem, the triangle proportionality theorem. And it says, if a line parallel to a side of the triangle intersects the other two sides. So this is the setup. We have this triangle and we cut a parallel line going through there. So this line is parallel to the opposite side. Then it divides it proportionally. Now, what's easy about this is it basically sets up your proportion for you. You can just see, I shouldn't use A, B, C, D, but you can just see this new parallel line kind of acts like the bar of the proportion. You can just say blah over blah equals blah over blah, and the proportion is very easy to find. So make sure you have the right setup. Make sure these are parallel, and then if they are, the proportion is basically screaming to you. You don't even have to look for it. All right, let's look at this first example over here. Okay, so I want to find US. I'm going to put X here. You could just call it US, either way you wanted to go. If you kind of tilt your head to the side, you can see the proportion as it is. 10 over 4 is equal to 14 over X. And then we can just solve. 10X is equal to, 56, so X is equal to 5.6. And then you can always go and double check and make sure your ratio is right. I just like to look and make sure it's reasonable. 10 over 4, so 14 is a little bit bigger than 10. So US should be a little bit bigger than VT. 5.6 is a little bit bigger than 4, so it's a reasonable answer. Okay, y'all try the second one. Okay, same process here. 3 over X equals 2 over 5. The proportion jumps out to you. So X is equal to 15 halves. If you put that as a fraction, that's okay. I mean, as a decimal, that's okay too, but we prefer fractions. Again, a reasonable answer, so I know I got that right. Example 2 is using the converse of the triangle proportionality theorem. It's just going backwards. It's saying I have all 4 of the sides. I want to see if DE is parallel to BC, and the only way it would be parallel is if the proportion worked out. So I'm going to set it up like normal. 8 over 12 equals 10 over 15. And there's 2 ways you can check a proportion. You can either divide each side and make sure that the ratios are the same, or you can cross multiply and make sure you get the same thing. Either way, it's exactly the same kind of process. So I'm going to cross multiply. 8 times 15 is 120. 10 times 12 is 120. So I have verified, since these are the same, this proportion works out, then DE is parallel to BC. So that one's actually even easier than the other ones. All right, let's turn the page here. All right, same concept. This is called the two transversal proportionality theorem, or this is actually a corollary because it comes off the other theorem, and it is just where we have 3 or more parallel lines. So we're used to just seeing the 2, but I've added the third one on there. Now, these can come together and we can look at this as a triangle, but they don't even have to. It's like non-parallel lines. So we have 3 parallel lines here, here, and here, and then 2 transversals, and the transversals don't necessarily have to be parallel. They can be, but they don't have to be. And what we learned here is the exact same thing. This proportion basically jumps out at us. 1 over 2 equals 3 over 4. It's just right there glaring at us. We can use this parallel line as our fraction bars, in the middle as our equal sign. It's just that easy. So let's look at one. Suppose that an artist decided to make a larger sketch of the trees in the figure. AB is 4.5, BC is 2.6, CD is 4.1, KL is 4.9, and I want to find LM and MN. So I'm going to call this X and Y. So we're finding 2 things here, so I'm just going to have to do this problem twice, but it's the exact same thing. So the first time I do it, I'm just going to cover up this last section. And here is your proportion jumping out to you. 4.5 over 4.9 is equal to 2.6 over X. I hope everybody can see that proportion just plain as day. All right, so let's cross multiply. 4.5X is equal to 12.74. Divide that by 4.5, and we get 2.83 inches. And that, let's go back and put that on there. This is LM. I called it x just to keep it easy, but it's ln. So now I just need to use the same process to find y. So at this point, it's kind of your choice. You can either eliminate the middle one and still use your 4.5 and your 4.9, or you can eliminate that one and use your 2.6 and your 2.83. And it should be the same either way. The only thing I'll caution you of is, if at all possible, you want to avoid using numbers that you came up with. Because what if I made some silly typo in the calculator and 2.83 is not the right answer? If I use it again in the next part of the problem, then my next answer is not going to be right. So if I were you, I would still use this 4.5 over 4.9, and I would jump to this last one, 4.1 over y. That way, even if part A is wrong, part B, I'm still starting off on the same foot, so at least I have a fighting chance here. Alright, 4.9 times 4.1. And then divide that off. Y, 4.64, which is really there you go. There's the two transversal proportionality theorem. It's the same kind of concept. Set up your proportion as given in the problem, cross multiply and divide. This one is also along the same lines, only we are looking at the angle bisector. So AD is an angle bisector, and we learned in chapter 4 that that just means that we're bisecting this angle right here. So you can see the tick marks there. What happens here is, if this is an angle bisector, it sets up a proportion along the side lengths. This one you can also kind of set up pretty easily. On this side it says BD over DC equals AB over AC. I like to set mine up like this, 1 over 2 equals 3 over 4, and kind of use that angle bisector as your divider between your two fractions there. To me, that one just jumps out easier, so it's the same thing if you set it up this way, whether if you set it up this way, you're going to get the same theorem. I just think this one is easier. Okay, so let's look at this example here. Now this one has a little algebra in it because we have an x, so we're going to have to solve for x and then plug it back in to find PS and SR. So I'm going to draw my little fraction bar here, or you could even just use the bottom of the triangle. This is the equal sign between them, and then I'm going to set this up as it looks. X minus 2 over 32 equals x plus 5 over 40. Now, if you were looking at the last example where the triangle was rotated, and so you wanted to put the 32 over the x minus 2, 40 over x plus 5, you would get the exact same answer. It doesn't matter. As long as you don't jump and crisscross across the triangle, as long as you don't set it up that way, you're okay. Alright, so we did some of this on Monday where we did proportions with binomials in them, and we said, remember, it's just important that you put those in parentheses so you don't forget to distribute. I'm even going to write this one out so I can show you what I mean. So 40 times x minus 2 is equal to 35 times x plus 5. Then we distribute. So I have 40x minus 80 equals 32x plus 160. Okay, I'm running out of room. I'm going to move the 32 and I'm going to move the 80. So over here I have 8x. Yeah, and that crosses out. And then over here I have 240. So x is equal to 30. Now be careful here because this is not the end of the problem. They didn't say find x. They said find PS and find SR. So we want to make sure we don't forget to go and plug that back in. So 30 minus 2, this side would be 28. 30 plus 5, this side would be 35. And then we can kind of look and see, is this proportional? 32 is less than 40, so I know this side, 28, should be less than this side, which is 35. So that all kind of makes sense there. It works out. Okay, y'all try B. Don't let that fraction get in the way. Really work it out. Okay, so I set up my proportion, 8 over 4.5. I just put this and equal them right there. equals y minus 2 over y divided by 2. Now, you don't have to worry about this in this case because we're about to cross multiply and get rid of it, so don't freak out about the fraction in a fraction. So when I cross multiply, 8 times y over 2 is equal to 4.5 times y minus 2. That's why I said don't freak out, because 8 times 1/2 is just going to go to 4. And then I distribute this, move your sides, y is equal to 18. And then don't forget to go back and plug it back in. So if y is 18, then this side would be 16, and this side would be 9. I should probably box those. Here you can tell these problems are a little more difficult, so I went back and I plugged it in and I made sure that the proportion worked. 8 over 4.5 equals 16 over 9, and then I cross multiplied and I saw that I got 72 and 72. That way I just knew I did the problem right. So I was just kind of double checking myself there, which is not ever a bad idea. Okay, this is the end of 7.4.